Hello friends, this video on Redox reaction part 21 is brought to you by examfear.com. No more fear from exam. Let's take an example. We have to predict if the reaction between the following is feasible. Fe plus 3, I minus and all this. For this we'll just follow go to the slide we have, the last slide where we have the chart, and with that we can tell. So let's take Fe 3 plus and I minus, right? So we have these reactions. The reaction we'll have is a balanced reaction. If we have, this is Fe3 plus, we'll take one electron to give Fe2 plus, and I minus will give I2. Let's balance this, 2I minus, and sorry, this will give one electron. This will give you 2 electrons here. Let's multiply this 2 by 2 both sides so that we can balance the charge, right? This is the two reactions we have. Let's try to find the electron volt for both of these, right? So for Fe3 plus to Fe2, so Fe3 plus to Fe2 plus, we have this guy and 0.77, right? So let's write the value. So this guy is 0.77, correct. The next is I to I minus. So let's see if I have that value. That guy 0.54. So this is I2 to I minus is 0.54. So I minus to I2 will be minus 0.54, correct. So it will be minus 0.54. This is plus, this is minus. Hope you understand why. See, I2 to I minus, iodine to iodine ion is 0.54. So iodine ion to iodine will be minus 0.54. Correct. Now if you see, in this case it was correct. In this case we multiply with 2, right? So Fe3 plus to Fe2 was 0.77, but if you multiply with 2 also, in this case we multiply with 2. So let's add now. So 0.77 into 2, that is 1.54 minus this, that will come out to be 1 volt actually. So it is positive, so it is feasible, correct. Let's take the second one. We change the color. So I'm taking this guy now. So this is Ag plus and Cu. So the reaction will be something like this. Ag plus electron will give you Ag, and Cu will need electron, right? Cu becomes Cu plus 2. So Cu has to become Cu2 plus, so it will give 2 electrons, right? So it is 2, it is 1, so let's multiply this also by 2, correct. So now let's go to the chart and see for Ag plus to Ag what is the value. So Ag plus to Ag is 0.8. So into 2 we have, so 0.8 into 2 plus, right, volt for this. Now Cu to Cu plus 2. So Cu plus 2 to Cu is 0.34. So Cu to Cu plus 2 will be minus 0.34. It's minus 0.34. So you add this, you get 1.6 minus 0.34, the positive number, right? So that means this is also physical, correct. Let's take the third one. It is Fe3 plus and Cu, right? So Fe3 plus will try to become Fe2 plus and will give 1 electron, correct. Similarly Cu will become Cu2 plus, will give 2 electron. So this is 1, this is 2, we will multiply this thing by 2, and then you will add, you will get the balanced reaction, right, because you will get cancelled. Now let's go to the chart and see for Fe3 plus to Fe2 plus. Fe3 to Fe2 is 0.77, and 0.77 into 2 is the value here, so 0.77 into 2 volt, positive. Let's take for Cu to Cu plus 2. So for Cu plus 2 to Cu it is 0.34. So for Cu to Cu plus 2 will be minus 0.34. So it is minus 0.34. You solve this, this becomes 1.54 minus 0.34, 1.2 volt. It's also positive, so it is also visible. Let's take the next reaction. Silver and Fe plus 3. So the reaction is my silver becomes Ag plus, gives my electron. My iron Fe3 plus is reduced to Fe2 plus and it takes electron. Let's go to the chart and see the board. So for I have Ag to Ag plus. I have Ag plus to Ag, it was 0.8. So from Ag to Ag plus oxidized, it will be minus 0.8 volt. Similarly, Fe plus to Fe plus 3 it got reduced. So Fe plus 3 to Fe plus it got reduced is 0.77. So it will be plus 0.77 volt. So you find total, because it's all cancelling, so you don't need to multiply. You find total, it is minus 0.03 volt. So it is not visible. Correct. Let's take the next example. So I have Br2 and Fe plus 2. So the reaction goes like this. Fe2 plus will oxidize to become Fe3 plus, right? Because there's a property of iron. Br2 will get reduced to give 2Br minus. So here we will have 1 electron. Here we have 2 electrons, right? So we'll multiply this thing by 2. And if you add, you'll get the balanced equation, right? So now if you see, let's go to the table for iron reduction, for iron oxidation actually here now. So iron Fe2 to Fe3, right? So iron is oxidized, so it will become minus 0.77, right? Because 2 to 3. So the moment you oxidize, you have to, it will be negative. It's minus 0.77 into 2, right? Into 2. Because 2 iron. And for bromine it is getting reduced, so for Br, let me find this guy, 1.09 plus 1.09. So if you add this, this is minus 1. Let me write here, minus 1.54 plus 1.09. It is negative only, it is some negative value, minus 3.5, minus 3.5, yeah. So it's 4.5 actually. So this is a negative value, that means it is not possible. So thus you see, you have a combination given, you just have to find the net electron volt. If it is positive, that means this is feasible. If it is not positive, that means it is not feasible. So we have to arrange the metals in the order in which they can displace solution from the salt. This is something I know already. So we have, if you see the reducing power, magnesium, aluminium, zinc, iron and copper. This is, I'm talking about the reducing power. This is why, because magnesium will try to become Mg plus 2 because more stable. Aluminium will try to become Al plus, Al3 plus. This is 2 plus. Because it is more stable, right? So zinc also will try to become zinc 2 plus, but magnesium will want to become Mg 2 plus more desperately than zinc. And this is something which we have studied in the atom chapter, where we have discussed that everybody wants to attain stability. All the atoms want to attain stability, and some are more active because even if they lose only 1 electron, and they can lose 1 electron very fast, and they will become stable, right? Same thing with Mg and copper or Mg and iron. If you compare, you will see that. So if you want to understand more, it was the atom chapter where we have discussed these things in details. So the question says, given the standard electrode potentials for all these, we have to arrange in the order of reducing power, right? Reducing power is, you can say that which can reduce, right, or which can oxidize easily. Correct. So which can oxidize easily. So let's write everything in oxidized form. So oxidized K to K plus will be what? It is K plus 2K was minus 2.3 volt. So it will be plus 2.93 volt. Similarly, silver to silver plus will be what? It will be minus 0.8 volt. Correct? Just flip it. Hg to Hg plus will be what? Minus 0.79 volt. Mg to Mg plus 2 will be what? Sorry, Mg2 plus will be what? Plus 2.37 volt. And Cr to Cr3 plus will be what? 0.74 volt. This means that potassium will become potassium ion and it will give this much volt. That means it is more desperate, right? The maximum value is this. It is the most desperate. So this guy has the highest value. The next guy will be this guy, right? Because after 2.93, 2.37 is the less value. Mg. This is done. All right here. And then we have next least value is, I have this one, chromium. Positive value at least, chromium 0.7. And then out of these, which is least? The least is minus 0.80, and this is the next one. So this I'll write here, and this I'll write here. So this one is the highest reducing power. Correct. The last question, it says we have the galvanic cell and this reaction is happening. This is Zinc2 plus and this is Ag plus. So we have to say which electrode is negatively charged. So I have this zinc plus here, let it be zinc sulfate, and then I have here this, right? Now I have zinc here, or I have Ag here. So which electrode is negatively charged? So if you see here, the reaction will be zinc will become zinc plus 2 and give 2 electrons. And this electron will be used by silver ion to give silver. So if you see at zinc end, right, at this we have more electrons, right? More and more electrons, correct? So if we have more electrons here, what will happen? This guy will be negatively charged. Hope you understand. Since at zinc side we have more electrons coming out, right? So zinc will be negative charged. So zinc electrode will be negative charged. Correct? And the silver electrode will be positive charge. This is clear? This is done. The carriers of the electron current in the cell is what? Electrons. Obviously electrons are the ions. Ions or E minus, they are the electron carriers. And we have to find the individual reaction in each electron. This is the individual reaction. This is at the positive, this is at, this is the negative, and this is at the positive. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.